Hi students, today I am going to explain alternating current through a pure capacitor. Pure capacitor means no other component is connected, no resistor, no inductor, only capacitor is connected to the AC. But before going to explain this, I am going to explain why capacitor blocks DC. You know already, when a capacitor is connected to a battery or cell is a DC power source. When DC power supply is connected to the capacitor, what happens? So every capacitor is having the maximum capacity. ప్రతి capacitor కి ఒక maximum charge స్టోర్ చేసుకునే కెపాసిటీ ఉంటుంది. సో ఎప్పుడైతే ఈ maximum charge స్టోర్ అయిపోతుందో ఈ ప్లేట్స్ పైన, సో వన్స్ these two plates are storing maximum charge on them, then you cannot see current in the circuit. The galvanometer or ammeter which is connected here, it will show you the zero reading. The capacitor can allow DC only till it gets the maximum charge. Once it is, ఎప్పుడైతే కెపాసిటర్లో మ్యాక్సిమం ఛార్జ్ స్టోర్ అయ్యిందో అప్పుడు ఇది డీసీని అలో చేయదు, అంటే కరెంట్ ఇన్ ద సర్క్యూట్ బికమ్ జీరో. ఒకవేళ మనం బ్యాటరీ కనెక్షన్ తీసేసినాం ఆఫ్టర్ కెపాసిటర్ చార్జ్డ్ విత్ మ్యాక్సిమం వాల్యూ. సో ఎప్పుడైతే వెన్ దెర్ ఈస్ నో బ్యాటరీ, కెపాసిటర్ గుణం ఏంటి? ఉన్నప్పుడు తీసుకుంటుంది, లేనప్పుడు ఇస్తుంది. సో వెన్ దెర్ ఈస్ ఏ బ్యాటరీ ఇట్ విల్ టేక్ ద చార్జ్, వెన్ దెర్ ఈస్ నో బ్యాటరీ ఇట్ విల్ డిశ్చార్జ్ ఇట్. సో వెన్ ద చార్జ్ ఈస్ కమింగ్ అవుట్ ఆఫ్ ద కెపాసిటర్, slowly the current in the circuit increases. So when the charge in the capacitor becomes zero, then till the charge in the capacitor zero, the current in the circuit is there. So that means it is acting as a variable battery or variable cell. Capacitor which is charged with maximum value will act as a variable cell. So anyway, I am not talking about this particular topic because only I wanted to explain what is the difference between the AC and DC passing through the capacitor. When the capacitor is connected to a AC power supply symbol is this. What happens? After some time this becomes positively charged plate, this becomes negatively charged plate. When alternating EMF source is connected to the capacitor, what happens? So it is positive plate and negative plates go on interchange like this. The charge stored on the capacitor is alternatively changing like this because of its alternative EMF. But at any particular instant of time, the voltage across the capacitor is charge stored in the capacitor divided by capacitance of the capacitor. You know already, capacitance of the capacitor is charge stored per unit potential difference. Just I am writing this, V I am bringing here, C I am bringing here. So the potential difference across any capacitor is Q by C. So here this is Q by C. Now I already said at any particular instant of time, the potential difference across the capacitor is charged by, but any particular instant of time, the potential difference across the capacitor is equal to instantaneous EMF of this particular circuit. That's why in the place of E, you can write V E naught sin omega t. Assume that this is the potential difference across the capacitor. Now voltage across the capacitor formula, Q by C divided by E naught C sin omega t. Now Q by C you write here, just to write Q as it is and you bring this C here, it becomes C naught sin omega t. సో నేను ఏం చేసిన, ఈ C అనేది ఇక్కడ తీసుకొచ్చిన అప్పుడు C naught sin omega t అయింది. సో ఎందుకు ఇప్పుడు ఈ ప్లేస్లో VC అంటే గుర్తుంచుకోండి, ఇది ఎలక్ట్రిక్ ఫీల్డ్ కాదు, నార్మల్గా ఇది ఎలక్ట్రోమోటివ్ ఫోర్స్. ఇన్స్టాంటేనియస్ ఎలక్ట్రోమోటివ్ ఫోర్స్ ఆఫ్ instantaneous electromotive force of any alternating current is equal to E naught sin omega t అని తెలుసు. కానీ ఏ ఒక్క పర్టికులర్ టైంలో మనకు తెలుసు పొటెన్షియల్ డిఫరెన్స్ అక్రాస్ ద కెపాసిటర్ అంటే చార్జ్ బై కెపాసిటెన్స్. సో ఎట్ ఎనీ ఇన్స్టెంట్ ఆఫ్ టైమ్ దిస్ VC ఈజ్ ఈక్వల్ టు దిస్ E. That's why in the place of E I am writing VC, after that VC value I am writing here. సో అందుకే ఈ నాట్ సైన్ ఒమేగా టీ వచ్చింది. నేను ఇప్పుడు ఐ వాంట్ టు ఫైండ్ అవుట్ ద బై యూజింగ్ దిస్ ఈఎంఎఫ్ రిలేషన్ ఐ వాంట్ టు ఫైండ్ అవుట్ ద కరెంట్ రిలేషన్. మనం ఇప్పటివరకు చేస్తుంది ఏంది, ప్యూర్ రెసిస్టెన్స్ సర్క్యూట్లో కానీ ప్యూర్ ఇండక్టర్ సర్క్యూట్లో కానీ మనం ఏం చేసినాము, ఈఎంఎఫ్ రిలేషన్ తోని కరెంట్ రిలేషన్ కనుక్కున్నాం. సో ఇలాగే ఇప్పుడు కూడా కరెంట్ రిలేషన్ కనుక్కోవాలంటే ఇక్కడ లెఫ్ట్ హ్యాండ్ సైడ్ ఏముంది, క్యూ ఉంది. సో దట్స్ వై ఇఫ్ యూ డిఫరెన్షియేట్ దిస్ ఈక్వేషన్ విత్ రెస్పెక్ట్ టు టీ, I am differentiating this equation both sides with respect to t. So I can write like this, d by dt of CE naught sin omega t. You know dq by dt, charge per unit time, is nothing but current, is equal to d by dt. CE is coming outside because C is the capacitance of the capacitor which is fixed. The E naught of the particular alternating current is also fixed, peak value. So only the differentiation of sin omega t with respect to is there. Only sin omega t we are differentiating. Then you write I as it is. CE naught also you write as it is. But you know, differentiation of sin omega t with respect to time is omega cos omega t. This is pure differentiation. Differentiation of sin omega t is what? Omega cos omega t. Now you can write I is nothing but omega c E naught cos omega t. Now you just observe, this is a current, but this is electromotive force of peak value. This is the instantaneous current. But this current should be in terms of the peak value of the current, but it's not there. Just you rewrite this equation in this way. You write this E naught as it is, but if you bring this omega c, it becomes 1 by omega c cos omega t. Here this 1 by omega c is acting as a resistance of the capacitor. So 1 by omega c is acting as, every resistor is having its own opposition to the current, but capacitor is also having opposition to the current. This opposition offered by the capacitor is called capacitive reactance. This 1 by omega c is called what? 1 by omega c is nothing but capacitive reactance. Capacitive reactance is nothing but resistance only, there is no doubt. But in case of capacitor it is called capacitive reactance. So you know electromotive force means what? Voltage. Voltage by resistance is called current. So that's why this voltage by resistance, it should be similar to, it must be similar to the resistance. It must be similar to the resistance. That's why 1 by omega c is nothing but resistance of the capacitor. It is also called capacitance of capacitive. That's why it is also called capacitive reactance. Now I am going to write this current in terms of the peak current because it is in terms of peak value of the EMF. But I want to write a current. So you can write is equal to instantaneous current in the pure capacitive circuit is equal to I naught, E naught by, you know E naught means voltage, 1 by omega c is resistance. Voltage by resistance is nothing but according to Ohm's law, current. So that's why E naught by resistance is nothing but I naught cos omega t. Now already మనం తీసుకునేది ఎలక్ట్రోమోటివ్ ఫోర్స్ రిలేషన్ ఈజ్ గివెన్ ఇన్ టర్మ్స్ ఆఫ్ sin omega t లో ఉంది. దీన్ని దీంతో కంపేర్ చేయాలంటే దీన్ని కూడా సైన్ టర్మ్స్ లో రాసుకోవాలి. So we need to write this also in terms of sin. So you write just I naught cos omega t. You know sin 90 plus theta is equal to cos theta. So just I am writing it as cos theta ni sin theta laga rayalante cos theta is nothing but sin theta plus 90 degrees. 90 degrees is nothing but you can write like this. Sin 90 plus theta or sin 90 plus theta is equal to cos theta. So we already discussed E is equal to E naught sin omega t, we got it in case of capacitive circuit. But I is equal to how much we got? I naught sin omega t plus pi by 2. Pi by 2 means what? 90 degrees or pi by 2 radians. Now just to take the phasor diagram, assume that this is x axis and this is y axis. So the omega t is nothing but phase angle. So assume that if the E naught is making, E naught is, this is the phasor diagram of peak EMF. Peak value of the electromotive force is making an angle omega t with x-axis. This is E naught. You know already length of this phasor will give you the magnitude of the E naught value. But if you see I is equal to I naught sin omega t, how can you say this is plus sin omega t? Already E naught is making certain angle with the x-axis, but it is making extra angle pi by 2. That means what? It's very simple. The peak value of the current I naught is making 90 degrees extra, omega t plus 90. That means I naught and E naught, the phasor of the I naught and phasor of the E naught are perpendicular to each other. So you just see the instantaneous current at any time is omega t plus 90 degrees. This is 90 degrees. Omega t plus 90 degrees. But this is making only omega t. Now I am going to explain sinusoidal wave for E is equal to E naught sin omega t and I is equal to I naught sin omega t plus pi by 2. I already explained that this in the place of I sin 90 plus theta, I wrote cos theta. So just to see E equal to E naught sin omega t, this is I equal to I naught cos omega t. If you take the sine wave of this E naught, if this is the E naught value, this is the maximum value of the alternating current in a pure capacitive circuit, then when the E is equal to E naught sin omega t, I is at the same time, the I is nothing but I naught cos omega t. So the current will start here. This dotted line is showing the current, this solid line is showing the EMF. So this is nothing but I is equal to I naught sin omega t plus 90 degrees or pi by 2. But this is showing E is equal to E naught sin omega t. Just to see, that means what? Current and EMF are 90 degrees out of phase. Current is perpendicular to EMF in case of pure capacitive circuit. Also, when the capacitor is connected to AC source, if the current is in this direction, voltage is in this direction. This is called VC. VC means VC or EC or E, whatever it may be, all are same. So the voltage and current are like this. This is 90 degrees. The current always passes along the wire, but the voltage is behind the current because E is equal to E naught sin omega t. But I is equal to how much? I naught sin omega t plus 90 degrees or pi by 2 radians. So it means what? Current is having more angle. That means current is ahead of voltage by 90 degrees or voltage is behind the current by 90 degrees. So this way you can. But in case of resistance circuit, already you know, in case of pure resistive circuit, the current and voltage both are in the same direction. No phase difference. Here theta is angle is 0. But if you take the pure inductor circuit, we already discussed in the last class. If it is pure inductive circuit, if the current is in this direction, the voltage will be in this direction. This is VL. Voltage inside the voltage across the inductor. VL. This is because formula for this is what? I is equal to I naught sin omega t minus pi by 2. E is equal to E naught sin omega t. So in case of pure inductive circuit, this is omega t minus pi by 2. That means what? Voltage is ahead of current, but the current is minus pi by 2. That means it is behind the voltage. But here they are parallel to each other in case of resistor. But here current is ahead of the voltage. Here voltage is ahead of the current. This is the difference. Okay. Thank you, students.